Hello everybody, my name is Kenny Matsuura of the PCC Asia. The PCC nowadays is the largest manufacturer of interlinings in USA. This is the opening of our technical seminar on the video. It's a package to bring to the place at your most convenient time. The audience we expect is anybody who is professionally involved in the fashion business, apparel designs, and its production. Let me start with explaining what the interlining means to your garments. We say interlining works as bones, or rather skeleton of the garment, which support flesh and the skins of the garment to form three-dimensional shape to fit to the human body. Human bodies with so many hills and dents, ups and downs. The first prototype of interlining was hair canvas. Hair canvas was made of animal hairs like ram's wool, goats, or a camel's wool, even with the cotton materials. For some cases, even horse hair is used to give the ultimate resilience in a cross-section with a soft drapeness of a fine cotton in a vertical direction to make a nice three-dimensional body line. Use of a canvas needs an expertise of an experienced tailor. Not for every workers in the garment industry to use such a kind of thing. Therefore, that is how the fused interlining is introduced for the better efficiency in the quicker production of a garment. Today, we would like to concentrate to explain about the most core technical issues of the fusible interlinings, about the fusing operations, the testing methods, the maintenance of fusing machines and the potential troubles and its solutions. The one thing I want you to remember, you can change the buttons or linings or any other trim items on the garment if you do not like it. However, once you fuse the interlining onto your fabric, you cannot remove it. So please be very careful and how you choose the interlining, and please do test it before you apply it on the bulk production. Here we go.
This is the most commonly used fusing press machine. We call this a continuous press or roller press. The model number is KDK 900 with an intake size of 90 centimeters or 900 millimeters, which is about 36 inches. We call this style of fuse machine a floor-mounted type to differentiate it with a smaller type of machine with a 400 to 450 millimeter intake, which we call a tabletop type. A tabletop machine usually gets much less fusing pressure than floor-mounted types, therefore it is used for only fusing small parts. Major parts or front panels must be fused by floor-mounted machine. Let's try fusing some sample fabric. Use of Teflon-coated sheets help to smoothly slide the fabric and interlining into the fuse machine. Anyway, we need to keep the fusing area clean and open for smooth insertion into the machine. First, we must set the temperature with the thermostat and wait for a while until the heater elements are stabilized to the desired temperature. This thermostat is not always accurate, therefore the actual temperature in the heating chamber must be measured. We'll soon show you how. The speed timer is set to the desired machine speed. Mostly it is shown as dwell time or duration for a piece of fabric with interlining to go through the heater box. Now we are setting it to 12 seconds. This timer is also not always accurate, so we will show you later how to measure and adjust it. This machine is designed to give even pressure on the rollers mechanically, so the pressure is adjusted this way. There is not any simple way of measuring the actual pressure given, but we can test whether the roller is giving enough pressure or not. This is how we check the fuse line temperature using a thermostrip. The thermostrip is placed in between the fabric and fusible interlining to measure the actual temperature gained on the coated glue of the fusible interlining. The temperature rise is indicated as the blackened number on the strip, which is permanently recorded as the temperature reading. Measuring this glue line temperature is most important to determine the true heating condition given to melt the glue. This is a way of measuring the temperature in the heating chamber on a real-time basis. This electronic thermometer with a sensor probe line is useful to check the actual temperature against the thermostat setting. The actual temperature in the heating chamber is often different from the thermostat setting. This thermometer is not so expensive. We suggest that every garment factory obtain one of these. To check the actual dwell time, we use a stopwatch or simply look at the second hand of a wristwatch. We can check the time while we're actually fusing a piece of fabric. Start counting time when the head of the fabric is going into the intake opening. Stop counting time when you see the head of the fabric coming out from the outlet of the heating chamber. This is how the actual dwell time is counted. If you find the actual time is different from the timer indication, you can simply screw off the dial and reset it to the actual reading position. Then tighten the screw. Pressure value on the roller is difficult to measure, but there's a very simple way of testing whether the two rollers are giving enough pressure and if it's well balanced or not. For example, we set the pressure level at 2 kilograms per square centimeter, or 2 bar. Find 2 strips of 2-meter-long ribbons. Any wasted edge of narrow cotton twill fabric about 1 inch wide is perfect. Slowly start sliding a pair of long ribbons into the left and right side of the machine intake at the same time, this way. When the head of the ribbons comes out from the outlet opening, just shut down the machine. Then try both ribbons in each hand. Try to pull them out. If both are tight and not possible to pull out, that means enough pressure is on the rollers. If any one of the ribbons is sliding out easily, it means that side of the roller is not giving enough pressure. Either one side of the roller is worn out, or more likely, the roller axle is installed incorrectly. If both are coming out too easily, that means the pressure is all too low. It's time to change the roller or overhaul the machine. Peel bond strength of fused specimens can be tested by this machine. This machine is equipped with a load cell, and the bond strength is measured and transmitted as an electronic signal, then recorded on the computer connected to the machine. This machine can record the entire bond strength varied throughout the peeling process. We take an average of the peak and the low value to determine the average bond strength. This is the most common and effective way of measuring the bond strength. We use this precision handheld pull scale specially designed for this purpose. Normal fish scales are not accurate enough for the purpose. There are 2 different scales available but in the same size. One is with 1,000 gram or 10 Newton capacity. The other is with a 2,000 gram or 20 Newton capacity to measure higher bond strength for men's shirts or jacket fronts. In either case, bond strength is measured with fused specimens cut into 2 inches with strips. This graph shows how temperature and time are related to heat up the glue resin coated onto the interlining. For example, if the interlining is designed to be fused in between 120 and 140 degrees Celsius, setting the heater somewhere around 130 degrees would be quite safe. It may take 10 to 12 seconds to heat it up to the desired glue line temperature, but it will be maintained within the desired temperature range a bit longer. We call it the sweet spot. Instead, if you set the thermostat at 150 or 160 degrees, the glue line temperature rises quicker than the first case. However, as time goes a bit longer, the glue line temperature exceeds the desired temperature. This will cause an overheating and resultantly, the glue is overmelted and it will either strike through the fabric or strike back to the interlining side, and nothing remains in between the fabric and interlining, then failing to fuse the two together. The dotted curve shows what happens if you use steam alone or use steam along with the heater. The temperature goes up quicker by using steam, but only until it reaches 100 degrees Celsius. Once it reaches 100 degrees, the part of the steam that turned to water earlier will start vaporizing again and keep removing heat from the fabric and glue, preventing its temperature from rising further than 100 degrees or slowing the process. This illustration shows the section of the interlining with coated glue dots placed over the outer fabric, about to be fused together. Other than temperature with the dwell time, another factor, pressure, is very important to fuse two fabrics together correctly. If the pressure is not enough, the melted glue will only touch the surface of the shell fabric, then it will easily be peeled off when pulled. On the other hand, if too much pressure is given, glue will go through the outer fabric at the same time it will also strike back to the interlining side. It causes rough surfaces and a stiffer feel to the touch. At the same time, not enough glue remains in between the fabric and interlining to tie both fabrics. Fusing the interlining onto the outer fabric perfectly is almost like cooking a perfect fried egg. Over easy. Right temperature, timing, and pressure. A typical problem, bubbling after washing. It's a mismatching of interlining to the fabric. Another typical problem, differential shrinkage of fabric and interlining against either heat or water wash, causes uneven surfaces on the outer fabric side. Yet another problem, strike through and strike back. It will make the garment quite stiff. If the garment is stiffened too much because of overfusing, there's a quick fix if you don't mind some extra work. Prepare a handheld spray gun with either methyl or ethyl alcohol liquid in it. Spray it over the stiffened area and pat it gently. Don't overdose. It may melt the glue too much and cause partial delamination. Such delaminated parts may be amended by fusing it back with a dry heated iron. The conveyor belt and press rollers must be cleaned periodically. This shows how you can clean both by preparing a cleaning flag made of medium-weight plain cotton sheeting sewn onto a paper tube. This cleaning agent contains silicone in powder form to help clean the excess glue resins and dirt off the press rollers and conveyor belt. It is sold by most fuse machine dealers. We strongly recommend this kind of daily maintenance log hung nearby the machine. Recording machine temperature twice a day may help to monitor the daily condition of the machine and to track down any possible cause of problems with the garments. Sandwich fusing is not recommended. It not only causes insufficient heating of the interlining, but also is not very efficient compared with normal single fusing. In short, it's much faster to do a single layer fuse than a sandwich fuse, so why bother sandwich fusing? Double fusing may sometimes be applied to achieve reinforcement on the chest part of a coat jacket. Double fusing often causes double the heat shrinkage, where usually interlining shrinks 1% by heat. Double fused parts shrink 2%, for example. This may affect the fabric surface if the fabric does not shrink the same 2%. We usually recommend to use non-fusible sew-in interlining or a small chest piece as a doubling instead of double fusing the same interlining. If you definitely need to do this, you may consider cutting the double fused piece in a biased direction, but only after fuse testing. Basically, the fabric and interlining must be cut in the same grain direction, unless there's a very good reason not to do so. Saving yield wastage is not good reason enough. Both outer fabric and interlining are basically produced in the same way when it comes to the winding of fabric rolls. Fabrics are all pulled in grain direction, which causes more heat and wash shrinkage rate compared to the fabric's cross direction. Fusing it in crisscross direction causes shrinkage difference of both fabrics. Thus it will end up with permanent distortion or creases on the outer surface. We strongly suggest not to do this.